here for capacitor my kids. So in today class student basically I'll be continue, right? Student, I'll be continue here. So same thing kids. So what is the last questions here? That is I can say heat. So heat is nothing students. You can say work done by battery minus energy final minus energy initial. So yesterday already we have done these questions. So further students in today class, just here I'll discuss more problem based on this. So in today class, kids, that is a problem is majority, right? So be focused and be proactive, kids, which is highly required because it's a class of physics here. So be happy always, be focused on your mission, think positive, avoid distraction. Yes, my kids, it's highly required. So, beta, we have to start classes as usual here. This class, beta, I'll take up to 10 o'clock. Up to 10 o'clock, kids. So, here, beta, I'll discuss into the class. First year, many numerical. Yes, not a single numerical students. Many numerical here. So, be positive and be very much active, kids, for the class. Okay. So, without wasting time here, we have to start the questions based on this. Okay. Now I'm audible. I'm audible now, my dear. Confirm me once. I'm audible now. Okay. 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 Student, God bless you for confirmation. Beta, just put note down questions every kids. Beta, this is session for I can say my dear for 11th, 12th class. 11th class, beta, sir, what you are speaking? Uh, not listening. I'm audible. Yeah. How you are telling beta you are not listening? Some students already said he's listening to me. Okay. Beta, check your connection here because from my side everything is fine. Kids, from my side there is no connection error here. So beta, we'll go through questions here. So what is the question, students? You need to find heat. My dear, you need to find heat. So what is the this is the question, kids. This is first question for today class. My dear, you can say there is a capacitor C student. There is the battery are connected. You can say this is what? V-volt battery across the capacitor, my dear. Now we are same capacitor students. Now I'm connecting across 2-volt battery. What students? I'm connecting here across 2-volt battery. So here students, find heat. Student, find heat. Okay. So how can we do, student? Have a look. Students, this question here you can do. Solution of this question step by step. So kids, this is what? Step number 1. Beta, this is the initial configuration of capacitor of capacitance C. Now, dear, this is what? Capacitance of capacitor. This is the final, you can say configuration. But here we wish to find if I'll shift this capacitor V volt to 2 volt. So you have to find heat. Sir, this class for 11th. My dear, this is 12th class. 11th class, 10 o'clock. My dear, 11th class, 10 o'clock, my dear. Right. Okay. I'll see once here. She's lying. I don't know who is this is Malka. I don't know. I'll beta just remove this person first. Because there is no space for liar person. I can say on YouTube, this is a class here very sensitive. If you wanted to disturb anything, then this is not good for any kids. But I have a look here. But I be focus everyone. What is the question, kids? So question is, dear my dear, I can say that is what, kids. This is a initial configuration of capacitor. Now I'm switching, and this is what capacitance of capacitor remains the same. 12 battery. So find heat. So the first here, just find over here initial condition. What is charge on the capacitor? So you can say this is plus CV. This is minus CV. Now, students, I'll make because according to this arrangement, I'll write what is the charge on capacitor due to 2-volt battery. So, student, this is the terminal of capacitor are connected to a positive terminal. So, we can say Q is equals to CV. So, this is what, students, plus 2CV. This is what, my dear, minus 2CV. You know, beta, we have to find over here charge flow. Student, we have to find charge flow. Okay. So now, students, see here carefully. This is CV. And final is what? 2CV. Beta, initially CV here, finally you can say 2CV. So charge is what? Increasing over there. So first, first you can supply charge over there. This is the first condition. How to find charge flow here? So if your charge is increasing, so we can say final charge on capacitor minus initial charge. So what is the final charge? You can say this is what? 2CV. This is what? You can say 2CV. What is the initial charge? So you can say minus CV. So what is the charge flow? Student, charge flown which is equals to 3CV. Charge flown which sorry, my bad, 2CV minus CBR, it's a CV only. So charge flown through battery, student, that is, you can say CBR. So here B is to find heat. Heat, student, formula is said here. So that is what I can say in step number 2. So what is the heat formula, student? Heat is equals to work done by battery minus energy final minus beta g energy initial here. So work done by battery, how can we do? Q into V. So this is what? CV square. So minus 2 plus plus here, just keep in your mind. Minus 2 plus plus here. So plus you can say this is what? Charge how much going supplying here? CV. So you can say this is work done by battery which is equals to CV square. Work done by battery which is equals to CV square. Okay, now students, minus here. We have to find energy final. So what is energy final? How can we do beta? I said the formula for energy stored in a capacitor half CV square, half C, and V is what? 2 volt. You can say 2 to the 4 V square. This is cancel. So you can write here, this is 2 CV square. You can say this is what? 2 CV square. Energy final beta. How much dear? This is a 2 CV square. Now tell me, what is energy initial here? Energy initial which is equals to half CV square. Energy initial which is equals to half CV square. Right, beta? So energy final here you can write over here 2 CV square minus here energy initial. You can say half CV square. So this is CV square minus here. You can say 2 CV square, but take LCM bacha party. So you can say this is multiply by 2 minus here CV square. minus what you can say CV square. This is wrong here. What is the potential? This is 2 volt. So this is what you can say 2 CV square. Work done by battery is what? 2 CV square. Now students, you can say here, this is remains 2 only. So this is 2 CV square minus here 4 CV square. 4 CV square minus CV square upon beta g 2 only. So you can see 4 minus 2 here 3. 3 by 2 1.5. So what is your answer student? 0.5 CV square. This is what students point. Sir, how to find work done by battery? Okay, I'll tell my dear. I'll tell my dear. Look carefully. I'll tell bacha how this is. Beta space is not available here. Here. I'll beta now I'm going to move on next slides. Here only. Bacha, just be remember what is the work done by battery. Beta can you use Raman formula? Work done by battery. It's nothing bacha. You can say QV. It's what, my dear? You can say this is what? QV. So what is charge, beta ji? CV. What is charge, my dear? CV. And what is the potential here? 2V. So you can write here, students. That is what, my student? CV into beta ji 2V. So work done by battery kits, this is 2 CV square. My dear, is it clear for you? My dear, is it clear for you? Just confirm me once. Confirm me, beta. Okay, good, beta. God bless you. Yaar. Now, bacha, just do the more questions. Yaar. You will have it sure, bacha. You will learn here only. During live session, bacha, you will learn here. Okay. So, have a look, beta ji. Next questions. Beta, this is we have a capacitor. C student. C student. Here I'm calling here. This is potential across the capacitor minus V and plus V. Now, student, this is the first part of the questions. Same capacitor, my dear. I'm going to connect that is 3-volt battery. C remains same, C only. Find heat. Find heat. Student, do you want try? If yes, then you can try. After that, yeah, you can watch my solution. Anyone wanted try to do these questions? Anyone wanted to do these questions or I have to do? Okay, no reply. So I'm going to solve these questions here. Okay, have a look, kids. Beta, concept remains same here. Beta, in step 1, first you have to solve questions part first of these questions. So this is what you can say C. So we can write over here minus CV, and this is what? Plus CV. Minus CV, and this is what? Plus CV. Initial condition here. First part of the question. 2 CV square. Okay, answer. Student, answer to CV square. Watch, student. Wait, beta, wait in watch. My solution here. I'll solve it, then I can tell my kids. So this is what, student? This is 3 volt. This is C. Beta, this is, I can say this terminal of capacitor connected to positive here. So you can write over here, this is 3 CV. And this is minus 3 CV. This is what, my kids? Minus 3 CV. Okay. So now students, just go through here. In these two comparison, what is your initial charge and what is your final charge? If your final charge is increasing with respect to initial, so during finding charge flown, you can say final minus initial. If your charge increasing, then you can do, my dear, final minus initial. So this is 3 CV minus here plus, it's minus already, plus CV. So what is beta? I can say charge flown through the battery. That is what? 4 CV. Charge flown through the battery. That is what? 4 CV. Okay, fine. Now, students, I wanted to find first here work done. Work done by, this is what? Battery. So what is work done by battery here? Simple. Charge flown into V here. So you can see this what? 4 3s are 12 CV square. 4 3s are 12 CV square. Now, students, in step 2 here, step 1 I have done. Step 2, students. Now I wanted to find heat. I wanted to find heat. So what is the formula of heat here? Tell me first. Heat formula, I can say this is work done by battery minus energy final minus kits energy initial. So work done by battery here already I found 12 CV square minus here energy final beta, we can write over here only here. So energy final, you can say half C into, this is 9 V square. So energy final, you can say beta 4.5 CV square. Energy final kits, you can say 4.5 CV square. So here you can say 4.5 CV square. And what is the energy initial here? CV square only. 0.5 CV square. My bad, my student. So you can see 4.5 minus 0.5, 4 only beta. 12 minus 4 here. Answer, student, this is 8 CV square. Answer, student, 8 CV square. Answer, student, you can say 8 CV square. Here you can write direction. This is what? 4 CV. Then here 4 CV becomes here minus. So this is answer beta, not 2 CV square, student. Answer is 8 CV square. Answer is 8 CV square. Very wrong beta. Just check once your calculation, student. You will get it. Check beta once your calculation, my dear. You will get it. Okay. Now, student, have a look at next questions. Beta, question will help you here to kids. Kids, question will help you to understand, right? It's a hardcore truth. So keep in your mind. Same student. Let us suppose I'm considering here capacitance of capacitor. This is remains C only. But here I'm just giving you there is a potential drop 2 volt plus and minus. Now, students, for the condition capacitor beta same capacitance C only. Now, students, I'm going to connect. This is what you can say 6 volt a battery. Question remains same, my dear. Find heat. Student, find heat. Okay. So how can we do, student? If anyone are newly joined, so beta be stay in the meeting. Try to beta be focused on class. You will learn here. Beta very crucial topic of capacitor now, students, going on here, and very much important, my dear. So this is what, students, I can say step 1 here. Step 1 beta, first I'll solve here. This is part 1 of the questions. This is part 2 of the questions. Right. So my dear, first I'll solve my dear part one of the questions here. So this is what kids, this is remains C. So charge you can write kids, this is plus 2 CV because it's a positive here. Now you can say it's minus 2 CV. Because similarly you can write with a charge on a C capacitance. So this is what kids 6 volt here. So this is, you can say capacitor is connected to positive terminal of battery. So what you can say, 6 to the 12, 6 CVR. My bad. My dear, this is 6 CV plus, and this is minus 6 CV. Plus 6 CV beta and minus 6 CV here. Okay. Now beta, here first you need to find charge flow. First you need to find kids charge flow. So, charge flow, beta, it's a technique, my dear. Students, charge flow, this is a technique here. You must remember, keep in your mind how to find charge flow. Beta, be crystal clear here. If your initial plate of charge and final plate of charge, if your final plate charge is increasing, then you can say final charge minus initial charge. But if your final charge is decreasing, then what you can say, initial charge minus final charge, right? So this is, you can say, charge increasing here. So you can write kids plus 6 CV minus 2 CV, which is equals to, students, 4 CV, which is equals to, my kids, 4 CV. Okay. Now, students, I'm going to find work done by battery. Work done by battery. Okay. So how can we do it? Because this is 2 CV. So you are basically supplying 4 CV. Then we come 2 CV near. Because initial, my dear, 2 CV, final is 6 CV. So 4 CV you are supplying basically. So what is work done by battery? This is what you can say Q into V. Q is what? Charge flown. How much charge flown here? This is, my kids, 4 CV. What is the potential drop? 6V. So you can say this is 24 CV square. This is what? 24 CV square. 24 beta ji CV square. Okay. Now your what we is to find heat. That is a beta part of second of this question here. Right. Okay. So what about beta? This one here? Heat formula, tell me first, all of you. Heat is equals to work done by battery minus energy final minus energy initial. So what is the work done by battery? 24 CBA square. Energy final here, you can say half CBA square. So 6 is a 36, 36 by 2 here. So you can say this is what? 18 CBA square minus here half CBA square. So this is what? 2 to the 4, 4 by 2 here. So this is 2 CBA square. 18 minus 2 beta. What we can say? 16 here. 24 minus 16. That is 8 CVA square. That is what, my dear? 8 CVA square. Beta, now here, I'm giving you beta one more point. Beta, anywhere in the questions, if you are getting a heat is negative, means you did some mistake. You did some mistake, beta. So be remember this point. Beta ji, be remember this point, right? So what is beta? This is all about the things here. So be very much active here, solving these all kinds of questions, right? Okay. One more last question here for this pattern. Yes. This is one more last questions. What students? I can say, or I'm changing the format here because same thing, you can do. Okay, one more last questions you can take. Bacha, I'm calling here minus and plus. This is C beta. Now students, you can say beta. You will change bacha these questions a little. Yes, beta. This is a lower terminal. This is the beta upper, lower and I can say beta higher. This is beta is 3 volt. This is here. It's a I can say new pattern of questions here. Literally, I can say, but it's good here. Think everyone. Find heat. Student, find heat. Right, beta? Okay. Can you try once here, everyone? I can say who is unknown boy. This is one day he came, but I can say he is good in a study. I can say bacha. Because one day he came na, that day also very I can say class was interactive. So now kids, I'll do here. This is I can say first point. This is second point. So beta first here in step 1, beta we have to solve beta nicely. Students, you can say, sir, this is C. Beta minus V and plus V. So you can say beta Z minus CV, and this is what? Plus CV. Right, kids? Okay. Now students, I can say that is what? C. Beta, this is what? Students, 3 volt. But no. This is lower here. This is a higher terminal battery. So due to this, which I can see here, charge is what? Minus 3 CV. Minus 3 CV. Right. And this is what, students? You can say plus 3 CV. Minus 3 CV, this is what? You can say beta Z plus 3 CV. Now, beta, just tell me, initial is minus CV and final is what? Minus 3 CV. Which one is more here? Just tell me first. Minus 1 is more or minus 3 is more? Student, tell me, everyone. Minus 1 is more or minus 3 is more? All of you fast. Anyone respond me here? No response. Okay, I'm solving here. So definitely here, this is what? Minus 1 is more here, minus 3 is less. So I said, if your charge increasing, then you can say what? Charge decreases here, then initial minus final. Charge decreases, this is more, this is decreases. So charge decreases, so you can say what? If charge decreases, listen here, this is a crucial point. This is the crucial point, kids. Kids, this is the crucial point. Beta, minus CV minus 3 CV. So you can say minus CV is more, minus 3 CV is less. So if for this condition, you can say charge is what? Decreasing. If charge decreasing, so charge flown through battery, that is minus CV minus of minus 3 CV. So what is charge? This is 2 CV. This is what, my kids? 2 CV. Okay. So here, student, I'm finding battery, or you can say work done by battery. Work done by battery, which is equals to minus to plus plus only. So this is what? 2 CV into 3 VR. So you can say 6 CV square. Work done by battery is what, my kids? 6 CV square. Why charge all? Okay, new candidate. Why, sir? Why is charge flown always positive? Okay, beta, that is but I know charge ne yaar. So charge always flow from higher potentials to lower potential. So this is the way. If charge, this is the way formula. If your charge is final is decreases, so you can say initial minus final, right? Bachaji, if your charge is what increases, so you can say final minus initial. Always here you will get charges positive, charge flow on positive only, right? So now beta worked on a battery here. Now student in step 2, I'm going to find that is what kids heat. That is what kids heat. Okay, so heat is what? Work done by battery minus energy final minus energy initial. So what is work done by battery are 6 CV square minus energy final here. So energy final you can say 4.5 CV square. 4.5 CV square minus here zero point 0.5 CV square. This is 4. 6 minus 4. That is what? 2 CV square. That is what? 2 CV square. So be active here. Be active in the class. Okay, done everyone? Now kids, have a look here. Next questions based on this. But definitely, this is a new format, kids. This is a new format, kids. Hmm. So, what is kids? It's a basically you can say here it's a kind of switching problem. You can see my kids. It's a kind of switching problem. Okay. Take beta. Next numerical here. But here I'm connecting here. There are two capacitor. You can take it, students. There is one more capacitor. Student, there is now here I'm connecting in parallel another capacitor. Now, students, you can say now this is switches is open. Switches is what? Open, right? So, students, I can say for this condition here, let us suppose I'm calling this is 2 microfarad. Keep in your mind. This is 2 microfarad. Now, student, I'm considering here this is 3 microfarad. But here space ratio I couldn't picture. But keep in your mind, this is also 2 microfarad. This is also 3 microfarad. Okay. Here, students, I'm let us suppose considering here there is a potential drop, which is what? Plus minus 10 volt. Which is what, my kids? Plus minus 10 volt. Which is what, my kids? Plus minus 10 volt. Okay. Here, students, again here I'm considering this is plus 5 volt. Plus minus. So, kids, what is the question here? Once I'll close the switch after after closing the switch, find heat, find heat here, simple. Find heat, right? So how can we do, my kids? Come, very easy here. Beta, according to given solution here, step 1. Beta, according to given information here, first you need to write charge on both of the plate. So students, here you can say like this here. So now beta, we have to close the switch. We have to close the switch. Then we have to find heat, na? So you can say 3 10 the 10, 30 here. So for here, you can say 30 microcoulomb here, but I don't have a space. I'll not write. This is what, my dear, 30 microcoulomb here. Here, 2 5s are 10 students. You can say 10 microcoulomb, and this is minus 10 microcoulomb. Beta, be active. After that, student, what can I say for the conditions here? But I know here you can take care. Potential difference. For we don't know what it is because this is 3, this is 2. Across which beta I'm considering here. V1 is a potential drop, and here students I'm considering V2 is the potential drop. V1 is a potential drop on 3 microfarad. V2 is a potential of, I can say, 2 microfarad. Right. Okay, fine. So here students, what you can say? Yeah, this is at beta charge is more over here, charge is less over here. So what you can say, bacha, I'll make one more diagram here for better understanding. Charge flow beta start from what? I can say a capacitor 3 microfarad to 2 microfarad. Okay, so this is 3, this is 2. So you can write here 30 minus Q. And here you can say 10 plus Q. Here you can say 10 plus Q, right? So here finally you can say, kids, sir, you have taken here V1, and this is what? Here. You can say V1, and here is what? V2. And after closing switch, bacha, what you can say? Sir, V1 minus V2, which is equals to 0. V1 minus V2, which is equals to 0. So simply you can say, students, V1 is equals to V2. You can simply write, my kids, this is what? V1 is equals to V2. Okay. So what is V1 here? V is what? Q by C. I taught here in yesterday's lecture. V is equals to Q by C. So what is Q here? You can write over here 30 minus Q by 3 is equals to 10 plus Q by 2. Beta, do cross multiply. So this is what? You can see 60 minus 2Q is equals to 30 plus 3Q. So you can write, my kids, 60 minus 30 is equals to 5Q. So further, kids, you can write 60 minus 30 here. So 35. How much charge flown here? So you can say Q is equals to 6 microcoulomb. This is charge flown, bacha. What you can say? Q is equals to 6 microcoulomb. Now, bacha, this thing here, we can put over there, which is a part of, I can say, step 2, which is a part of students step 2 here. So 30 minus 6 here, you can write over here 24. And 6 plus 10 here, this is what? You can say 16. So you can say this is plus 24. This is minus 24. This is beta how much? 16. This is plus 16. And this is minus 16. So here you can take across of which, let us say V across, that is the final condition. Final condition beta, you can take here. V is the potential of the battery. So here we are, you can write. How can we get? So you can use here. This is 3, this is 2. So you can apply Q is equals to CV. So you can say V is equals to Q by C. So what is charge? 24 by 3. So you can say V is equals to 8 volt. You can say V is equals to 8 volt. Perfect here. But our questions remain same here. We have to find heat. We have to find heat. So step 2 bacha, step 3 are where I have to do. I'll do beta here only here because I have space. Yes, kids. So in step 3 here, I'm going to find that is what student heat. So yeah, what is I can say main point for these questions. In these questions, kids, there is no, you can say battery. There is what only capacitor. There is what only capacitor. So student for this condition here, what can you do? Student for step 3, what you can do? There is a different formula of heat, kids. Just keep in your mind. There is a different formula of heat. What you can say? Energy final minus energy initial. Energy final minus kids energy initial. So yeah, tell me what is energy final? This is here. Energy final beta. This is also your energy final. This is also energy final. So you can say half CVA square. So energy final students, you can say half 3, 8, 8 ja 64 plus 1 by 2, 2 into 8, 8 ja 64. Energy final done here. Energy initial half CVA square. So half into 2, 5, 5 ja 25 plus half into 3 and 10 10 ja 100. So beta, we have to solve here patiently beta. That is a different format of question, kids. So you can half here, you can take common everywhere. 64 into 3, 4 3s are 12 and 6 3s are 18 plus 9, 192. 192 plus 64 2s are 128. 128 minus here. 25 2s are 50 plus 100 here into 3. So this is what you can say 300. So further solve, kids. So this is half 192 plus this here 8 plus 2 10, 9 plus 1 9 plus 2 11, 11 plus 1 12, 112 and 3 320 minus here you can say 350. But you can say, sir, how possible? Energy we are heat we are getting negative. So some mistakes over there here. Heat never be negative. Heat never be negative here. I'll check once. Half CVA square, half into C and V is what 80 to 64, half CVA square. Correct only energy final minus here half of 5 5 are 25. Okay, 3 into 100, correct here. So you can say where is beta 8 plus 2 10, 9 plus 2 11, 11 plus 1 12 and 1 plus 1 2 plus 1 3 320 here. Minus 350. How it's how students? How possible here? Literally, there is some mistakes here. There is some mistake, kids. Formula here, you can see energy final minus energy initial only. Energy final minus energy initial. Sir, half of 300. Where, beta? Half I have taken out, na, beta, ji. Beta, half I have taken out, na, my dear. Where is mistake, kids? Uh, 4 threes are 12, 6 threes are 18, plus 1 19. This is correct. 8 plus 2 10, 9 plus 2 11, 12, 1 and 2 3. This is 350. Heat beta not must do negative here. That is there is definitely some wrong approach. Everything is fine. Data correct only. Yeah, I'm not able to find here, but there is some mistakes. Heat beta never negative. Heat never negative. What is the mistakes here? Should I check once? Energy initial. Okay, 25. Oh, ho, 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 ho. Yes, I got it. Mistake is there in the beginning of solution here. Okay, I'm giving a next numerical. We'll see here. We'll see here. Right. If we get answer over here correctly, then your approach is correct only. No, but same question here. I'm doing by short trick. Same question, beta. I'll do by short trick here. Yes. Here, beta, is something different here. Then I'll get from here only. But it's literally a very time saving approach, bacha, in the paper hall. Same questions here. But I'll take data only here. Okay. We'll verify from here also, bacha. This is 3. And this is connected to 2. 5. This is 2 plus minus 5. And this is plus minus 10. Correct now? Correct here. So how can we do these kind of questions here? By short trick. Beta, first here, just put the charge over there. Yes, here. Should initially write charges on both of the plate. So this is, you can say 30, minus 30, 10, and minus 10. So, beta, we have to first find what is the charge Q equivalent, Q net. What is short trick here? Q net is equals to C equivalent into V. Beta, we'll get directly here, V from here only. Q net beta 30 plus 10 here. That is what? 40. Beta in parallel combination, I didn't teach here, just keep in your mind. Parallel simply beta. We can apply a formula of resistor series combination. So 3 plus 2, this is what? 5 V. So potential difference, that is what? 8 volt. No need to do entire calculation here. We can go through short trick only. This is what? You can say 8 volt. Right. So this is where further I'll verify the solutions here only. Next question. But this question do by short trick here. And find heat. This question which find heat here, which I'm giving you informations. I'll take data a little carefully. This is 4 microfarad. Now beta, I'm going to connect here another capacitor. I can see there is a switch. Once I'll close the switch here, then we have to find heat. Bacha, this is changes here. It's minus and 4 volt plus. What data I have to take here? You can say this is 4. Then beta will get correct answer here. You can take plus minus 6 volt. Question remains same. We have to find heat. My dear, questions remain same. We have to find heat. Okay. We have to apply short trick here. So you can see here what? 6 4 is 24. And this is what? You can see you can take here 1 microfarad. So this is -4, this is +4. So you can apply bacha party. Conservation of charger here only. So what you can say again, Q net is equals to C equivalent into V. What is Q net? 24 minus 4. C equivalent how much? 4 plus 1 here, 5. V. 20. So you can say what is common potential here? Which is equals to 4 volt. Correct na? Correct beta. So we wish to find heat here. Here I'll solve here carefully. Heat beta ji, you can say energy final minus energy initial. What is energy final here? Half into 1 into 4 whole square plus half into 4 into 4 whole square. Energy final minus energy initial here, half CV square. Half into 4 into beta ji 6 whole square plus beta ji half into 1 into here 16. 4 for the 16. This is the condition. Half again here, I'm taking common from everywhere. 4 4 the 16 plus 4 4 the 16 4 the 64. 64 minus here. You can say bacha 4 and 6 6 the 36. 36 into 4. 36 into 4 what how much here? 36 into 4 144. Correct near. 36 into 4. This is what? 144. Oh, beta got it. Vedic vision. Beta got it, my dear. Wrong here. Energy initial minus finance heat ne beta. Vedic beta. You know, energy initial loss. Heat means loss ne beta. I was also doing means I didn't think here. Heat means what beta? Loss. So loss what we can say? Initial minus final beta. Then we'll get answer here. Vedic beta, everyone. This is also correct here. Vedic bacha, this is correct bacha. So this is what beta? You can say energy initial minus energy final here. Then correct bacha. 350 and 30. 30 by 2. 15 here. Perfect. 15 microjoule. 15 microjoule. Beta Vedic, are you there, my dear? Vedic vision, are you there, my dear? Beta, if there is no battery, here, then you can say energy initial minus final. Energy initial minus final here. If there is no battery. If there is no battery here, then you can say energy initial minus final beta. Loss here. Sir, is it because work done by battery is 0 in this case? Ah, you can think like that. Good, good, good. Very good. Vedic Bacha, you're a good candidate here. From where are you? Are you from Bangalore or are you from like with some other part of India? You're a good candidate here. I can say you are staying in the I can lifestyle in the last 1 hour here almost. Hmm. Good beta. Keep it up, beta. I'll be with you, my dear. So this is what beta? Again here 36 correct here. And beta you can see this is what 16. So this is beta how much? 6 plus 4 10 here. 4 plus 1 5 6 160. 160 bacha party. Entire beta 1 by 2. So you can say this is what? 1 by 2, my dear. Okay. 64 plus 60 beta 18 here. Yes, you correct beta. 80 bacha ji. This is minus here. This is plus. This is plus. This is entire minus here. So this is you can say 160 here or 160. Correct na yaar? 160. So 160 minus 80. 80 80 by 2. 40. 40 microjoule. That is correct bacha party. Sorry. Ah, very good. Also, yeah, I feel very interactive with you, beta. Vedic Vision. Tell your name here so that I can call you by your name only. Oh, this is not finished, beta Vedic. I have to change the notes. sequence beta. Vedic, is there any pages available? Yes, one pages I found. So beta, this is a question, sir. By the way, beta will help you a lot. Hmm. Okay, do beta next question here. Kids. Find potential across the plate. Find potential across the plate. Okay, figure shown. Find potential across the plate. Figure shown. Okay, so what's the figure, kids? 6Q, 3Q, this much here. So we have to find, let us say, V is the potential. So what is the value of this V? What is the value of this V? Okay, then how can you do by chapati these kind of questions here? Beta, very easy here. My kids, it's very easy here. Beta, you just be remember how to find charge outside the plate. This is the method here. This is the method, kids. So how to find the student charge outside the plate here? Very simple. Students, what is we have initial charge? Summation of initial charge by 2. This side also. Summation of initial charge by 2. This side also. How students? Also you. This is 6Q. This is minus 3Q. So you can say 6Q minus 3Q. 6Q minus 3Q by 2. So 3Q by 2. This is what you can say 1.5Q. This side also beta. And you can also write same thing here. 1.5Q this side. But we balance charges here. You know, charge is remains conserved quantity. Charge is what, my dear, remains conserved quantity. So you can say, bacha, sir, outside the plate, charge is basically 3Q by 2. And this is 6Q. This is 6Q. So what is the charge? I can see this side of the plate. It's very simple, bacha. You can say 6Q minus 3Q by 2. 2 take LCM here. So you can say here 6 to the 12. 12 minus 3 beta 9Q by 2. So what is charge over here, my dear? This is 9Q by 2. This is 9Q by 2. Okay. So this is here 3 by 2Q. This side beta. So what is charges over here? What is the charges over here? So simple here. Here plus beta 9Q by 2 here. As I said here, that is the basic definition of capacitor. Capacitor here you can treat as a dipole. Very beta convenient for you. So inside students, this is what you can say 9Q by 2. This is what, my dear? 9Q by 2. So you know what is the potential beta G? V we used to find here. So what is the potential? V beta G no formula here. You can say Q by C. This is what, my dear? Q by C. C you can take here. That is system capacitance here or plate capacitance. So you know there is a logic here. What is Q? Q you can say, bacha, this is charge present higher potential. Charge present higher potential of inner plate. I'll write over here. Yeah. What is Q? Charge is at higher potential plate. So this charge beta higher potential plate here. So what is Q, students? This is 9 Q by 2C. So this is here, I can say potential across the plate. This is what, my kids? Potential across the plate here. V is equals to 9Q by 2C. Literally, these all are point numbers. Yeah. Literally, I'm just teaching you very relaxed mode here. Not in much in hurry. But classroom not possible at all. In classroom, but I know there is a completion of syllabus here in hurry only. But here we relax. Teach nicely to kids. Right. It's beta very good thing here. Now beta we'll do here. We have many questions, bacha ji. Many questions here. Every question here will find what is the heat. What is the heat? Beta Vedic vision. Find paper here. Ah, again I found one paper. Again I found one paper. Right. So what is the question, student? Come here. I'm trying to find here good questions right now. Because this pattern of questions you can do beta Vedic. This pattern of questions Vedic you can do. We have to do hard questions here. We have to very hard questions. Okay, come. I'll make a separation beta because this is a long question, but very new questions here and very challenging questions. It's a very new question and very challenging question beta Vedic. So beta we very I can say focused here. Beta questions remain same. I'm not repeating again here. I'm writing once. Find heat. Find heat. Figure shown. Find heat figure shown. This is the question, kids. This is a different kind of question, beta. You know, this is, we have a capacitor. This is a capacitor. Let it, just think like that. Charge is mentioned. Let us suppose I'm considering, beta, here I'm considering 50 microcoulomb. And here, students, I'm considering minus 50 microcoulomb. Students, I'm considering C is the capacitance of capacitor. This is 10 microfarad. Beta questions remain same here. There is a switch. Now beta, it's not in switch closed condition beta. It's a switch open. Battery can take beta Z. Basic vision. This is 10 volt. This is 10 volt. Right. So beta here we have to find heat here. New question challenging here. Coming all question very much new and very good. Coming all questions very much new and very good here. Right. So be very much active here, boys and girls. Be very much active here, boys and girls. Okay. So what beta? How can we think questions here? It's a new question for you, na? But it's a very, very common here. Beta for this condition, C is mentioned. C is what? Mentioned. So here if C is beta, C capacitance of capacitor mentioned here. So you can find first V across the capacitor from logic. So first beta in step 1 for the solution, I'll find here what is V across the port battery. Capacitor here, sorry. Beta initial information mentioned charge on a plate plus 50 microcoulomb minus 50 microcoulomb. Beta capacitance of capacitor is mentioned. Beta here I'm going to find here V. So V is equals to what can I say? Q by C. So what is the charge beta? You can say 50 by 10, which is equals to 5 volt. Beta, that is a condition here. 50 by 10, which is equals to 5 volt. 50 by 10, which is equals to 5 volt beta. First part of the question here. Now beta, we have to find what is the charge flow. What is the charge flow? So beta, what is this is initial charge here. So beta, you can this capacitor you can connect here as usual. Now, what I said previously, kids. This is the capacitor connected to 10 volt battery. You can treat here this question like this. So beta, you can step here. So step one, step two. Okay, so this is 10 volt. This is also 10 microfarad here. So you can write over here 100 microcoulomb. This is minus 100 microcoulomb. So we have to find charge flow. We have to find charge flow. So what is the value of charge flow? Tell me everyone. What is the value of charge flown? I said here how to find charge flown. If charge is increasing, so final charge minus initial charge. You can do like that. So charge flown, student, you can say 100 minus 50, which is equals to 50 microcoulomb. So you, what you can say, you are basically supplying charge over here, 50 microcoulomb. So now tell me, in step 3 beta, Vedic vision. That is what, a student? Step 3 here. Work done by battery. Work done by battery. Work done by battery. So beta, what is the work done by battery here? Q into V. That is Q into V. So this is what you can say work done by battery beta. You can say 15 to 10 here. So work done by battery, which is equals to 500 microjoule. 500 microjoule, right? So we have to find heat. We have to find heat. So what is heat, student? How can we do here? How can we do, my kids? In step 4. Step 4 beta. So you can say heat is equals to work done by battery minus beta. Work done by battery, here formula remains same here. Energy final minus energy initial beta. So what is work done by battery here? We already found, which is equals to 500 kids. So we can say 500 minus here. Energy beta ji final. So energy final beta, we need to calculate, my dear. How can we do bacha energy final? Tell me quickly. Energy final half CV square. Half C state V square 100 50 50 50 500. Half CV square, you can write here. What is the energy final here? Half CV square. So you can see this is what 500. Energy initial here half CB square. Half CB square. So half C 5 5 is 25 25 125. This is what you can say with charge 125. This is what 125. Oh, Vedic. Beta, tell your name here. How you are didn't tell your name and location from where are you watching. You're a good candidate here. I'll give some tips and trick for your mission. Hmm. Yes, tell me your location and name. I'll guide you. You are a good candidate. 500 minus here. This is what 375 beta Vedic. This is 375. So 5 minus 375 beta. How much coming beta Vedic? This is 125 microjoule. 125 microjoule. Very good here. Good support of I can see for Vedic vision. Now beta Vedic next question here. It's a good question, Bachcha Party. Highly good here. I'll make beta, I can say these all beta questions already uploaded or need to upload it on YouTube here. Anytime you can go and explore. Come beta. We'll do yeah, one more questions. So what is the question, beta Vedic? You are genius candidate. Vedic pigeon. Okay. Vedic next questions, but be aware. Beta, this is the capacitor which is fully charged. Connected to I can see with a battery, but now we can see it. Switch is not closed. It's open switch. Okay. This is you can take with 10 microfarad. I'll take your same questions. This I see the potential beta. This is 100. Vedic beta, what I have taken the initial data? Do you remember? Vedic beta, what is the data I have taken? Charge initial on the plate. Maybe I have taken 50 Vedic. Am I right? 50 microcoulomb. No, beta. Initially, previous questions. Just now we finished na beta Vedic. What I've taken initial charge on capacitor? That is the final na beta. Maybe I have taken beta 50 Vedic. Can you check once your notes? 50 beta. This is beta 10 volt. Question remains in bacha. Find heat if switch is closed. If switch is closed. Okay. Vedic beta, try once here. I wanted to drink water. Do once here. Break for I can say 30 seconds. Oh, 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 oh. Oh. Answer beta. What is your answer coming? Okay, I hope you solve here, but I'll do here. If you've done, then well and good. Otherwise, you can do with me or watch my solution. In step 1 beta, first we have to find potential. V is equals to Q by C. Q beta how much? 50 here. So 50 by 10. As usual, you can write 5 volt. Step 1 done. Student, have a look here. I can see for step 2. For step 2, right? What beta? Just forget here. What is initial charge? Make beta the new diagram. After closing the switch here with a 10 volt battery, this is what gets 10 volt. So you can write over here. This is minus 100. This is plus 100. Now, by the can you tell me, please, what is the charge flown? Tell me, because you asked previously. Can you tell me better Vedic for this question? What is the charge flown? What is the charge flown? Vedic. Tell me beta. I'm looking your answer here. Okay, you answered already. Very good. 50. 50? I think so. No. Can you check once? No. Oh, because you answered na for what is the initial charge I have taken. Okay. Vedic which just tell me what is charge flown here through the battery. Through the battery after switching. After switch, if switch is closed, then find charge. Simple here. I see na beta Vedic. If charge decreases, so I can say initial minus final. Simple. If charge decreases, then initial minus final. So what is charge flow here? Which is equals to 150 microcoulomb, which is equals to 150 microcoulomb, right? Now, students, I'm going to find work done by battery, which is step 3. This is what, kids? I can say step 3. Work done by battery. So, students, you can say work done by battery, which is equals to QV. What is Q here? 150. And V is what? 10. Final condition we can take. Don't take initial condition of this voltage here. No, not. No, better. Okay. Uh, so QV beta, you can say here this is 150 into 10. Oh, work done by battery, which is equals to 1500 microjoule. Work done by battery is what? You can say 1500 microjoule. Super here. Now, beta, have a look here. Step 4 to find heat. Step 4 to find heat. Right. So heat formula beta I can write first here. Heat is equals to what? Tell me. Work done by battery minus energy final minus energy initial. So work done by battery beta 1500 microjoule. Yeah, I wanted to find energy final here only. Half C. C is what? 10. Half CV square. So V square 50. 500. Yeah. This is what you can say. This is what you can say, bacha, 500 only. This is 500. Minus energy initial here. Half CV square. Half CV square. But 25. 25. 125. This is remains 125. So we can say beta 1500 minus 375 na, yeah. 375, correct. So you can say 1500 minus 375, which is kuch beta how much here? 375, 25, 400, 1125, 1125. This is 1125 microjoule. Oh, me and your answer together only. Very good. Basic vision is, I can say, rock star for today live session. Live session interesting because of this kids only. Basic vision. Good beta. Stay connected here. Now beta, have a look here. Next question, because I have a remaining 8 minutes. So I'll take beta at least one question, kids. Hmm. I can take one question here only. Here. Come beta. Come kids. Who's telling us, sir? Okay. Oh, new candidate. Good. Yes, beta. Question remains same, kids. We wish to find heat. We wish to find heat. Okay. Vedic same question or different? Different question I can take here. Different question I can take here. But there are two parallel plate capacitor. This is now initially with a switch open. You can take here any data, don't worry. We'll see. Now it has it's switch open here. you can take students 20 volt. What is capacitance I have to take here? It can take 20 microfarad. It's a necessary near. I have to think. Uh, then this is 100. Oh, both are positive only. 100 and 300. It's a new question here. Interesting, bacha. Interesting, kids. Okay, fine. How can we do, bacha? Yeah, one thing are pretty sure. This question a little different format. So be focused with the vision, right? So bacha, first we have to find here what is the charge, because this is a positive charge, isn't there? Both plate charge is what positive. So for this condition, we have to find what is charge enclosed, which I taught here already. So first, you can take better like this here. Just let it be entire diagram. You can think about this one only. So you can say, sir, this is the capacitor. What is the potential here? V is equals to Q by C. You can write V is equals to, but you can say, what is Q, sir? They both have different charges. Yes, I'm telling Bacha, but 300 plus 100 here, 200. 300 plus 100, 400 by 2 years. You can say outside charge is what? 200. Here also bacha party. Outside charge is 200. Now here, what is initial charge over here? 100. What is charge initial over here? 300. So this is 300, this is 200 here. Means you can say here 100 charge over here. If this is 100 here, so you can see bacha over here. Here. What is charge over here? You can say here, this is what? Minus 100. Yes. But remember, listen, bacha, Vedic, I'll repeat. Students, I'll do here this thing. Let it be. First here, find charge outside the plate. 100 plus 300, 400 here. I said Q1 plus Q2 by 2. How to find charge outside? Q1 plus Q2 by 2. 100 plus 300, 400. 400 by 2 beta. So you can say this is what? 200 outside charge. Here also you can say this is 200. But you know here, charge is what? Conserved quantity. So this is charge remains conserved here. 200 outside. So you can simply say, na, sir, 100 inside of this plate. Beta, what is initial charge here? It's 100 only. Charge must should be conserved here. So what you can say, sir, basically 100 minus 200. So this is what? 100 microcoulomb charge. This is the I drawn. Just I wrote here what is the charge on the plate of capacitor. Initially, before switching, be keep in your mind, this is things which I have done for before switching. This is which I have done, I can say for before switching. Right? Okay, fine. Now, beta, I'll switch. I'll connect the switch. Let it be. Just forget this one. Step 1. This is step 1. Now, beta, have a look here. For this question, step 2. For step 2, now students, simply you can think here. You have a 20 microfarad capacitor which is connected to, now I'm closing the switch, which is connected to 20 volt. This is 20 microfarad. So what is charge over here? What is the charge over here? Think. Plus near. So this charge can't take outside. You can take these charges inside basically. So this 20 is a 400. So here you can write it as a charge inside the plate 400, and this is what? You can say minus 400. 400 and minus 400, right? So here for this condition, think we need to find charge flown. We need to find charge flown. So what is charge flown? Just think about inside here, because we have outside charges. So no need to think about outside charges. We think about only inside charges. So you can say charges are initially inside the plate increasing. So you can say final minus initial. Keep in your mind here. Beta, this is a final minus initial here. So you can say this is 400 minus minus plus. So what is the charge flown through the circuit? This is what you can say 500 microcoulomb. This is what you can say 500 microcoulomb. Now here we got one charge flown which then here you can say charge increasing na here. So we are supplying charge. How much charge supplying here? 500. How much are supplying here? That is what? 500. So in step 3 beta, first we have to find work done. First we have to find work done. So what is work done here? Q into V. So how much Q? 500. And what is V here? It's 20 only. So what is work done by battery? This is work done by battery. You can see here, it's a 10,000 beta Vedic. Yes, 10,000 microjoule. You can say that is what? 10,000 microjoule, right? Okay. Then beta, we have to find heat. We have to find heat here. Beta, space is not available here. You can just be continue wise. We continue here. Step 4. For heat is what? Work done battery minus here. Energy final minus energy initial. Student Jai Sri Sham. Oh, 10 o'clock. Boy, give me seconds here. Right. But I'll start your class around 10 here. Yes, beta, give me a little time here. Right. So this is the questions here. I want you to do at least one more questions. Yes, sir. At least beta, I want you to do more question here. This concept here finished. Jeet, beta, you can come 10 beta. I'll start your class 10 my dear. Now, kids, I'm taking classes of 12th class. Okay. I found beta Vedic. One more page. This is a last session and last. This is a questions for switching program. Yeah, you can say like that. Okay. Beta, make separation first here. Kids, make separation first. Yes, beta. So what is the questions here? I can take beta. This is 5 microfarad. This is 60. This is minus 60. Charge already mentioned here. Bindas. Now, beta, this entire setup here, I can say I'm going to connect. This is switch open here. You can take 10 volt. Find heat after closing the switch. After closing the switch. Okay, come beta. How can we do it? Beta, we go slow here. We go very much slow. Beta, charge is already mentioned here. So we can find potential first. In step 1. So what is the potential? Q by C. So 60 by 5 here. You can see this is 12 volt. This is what you can say 12 volt. Okay. Now students, I can say for step 2, no need to disturb this one here, let it be. But we can think here after closing the switch. This is the capacitor which is connected to 10-volt battery. 10-volt battery beta. This is a 5. So 10 5 is a 50. 50 microcoulomb. And here kids minus 50 microcoulomb. Minus 50 microcoulomb. Right. Okay, think beta from here these two steps here. What is the initial charge? 60. What is the final charge? 10. So charge is what? Increasing or decreasing? Tell me first. Your charge is increasing or decreasing? Decreasing. So what is it conditions? Tell me. Charge flow. Charge flow. Beta, how much here? Charge decreases to initial minus final here. So initial charge is what? 60 minus here 50. So what is this? Is 10 microcoulomb. This is 10 microcoulomb. Now beta, I'll find because 10 coulomb is what? Coming out. 10 coulomb is what? 10 microcoulomb charge is what? Coming out. So we have to find here. That is work done by battery. That is what work done. Sir, I think final answer is 10 microjoule. Vedic beta, I'm solving beta. I'll tell. I'll tell Vedic beta. Work done by battery. What is your Vedic work done by battery? Can you write in chat box? What is your work done by battery? This is what QV here. But plus to minus, keep in your mind, it's minus here. It's minus 100 microjoule. This is due to this, I took this question there. Because everywhere now I have taken plus. That is condition here. If charge is flowing, bacha, positive to negative. So this is what? Positive to negative before answering. You can put negative sign. But if your charge flowing negative to positive, so you can see that is what? For that condition, positive only. So work done by battery is minus 100 microjoule beta. Vedic. Very good. Vedic. Correct beta. Now, my dear, I can say next picture, that is BB is to find heat. I can say step 1 finish, step 2 finish, step 3 beta. Step 3. So this is what? Heat. Heat is what beta? Work done by battery minus energy final minus energy initial. Energy final minus energy initial. RB already found. Work done by battery here, which is equals to 100 microjoule minus air. Energy final beta. This is in a condition half CV square. Half C means half into 5 into 100. 125. This is what you can say. Correct, near 100 by 2. No. Wrong. 250. This is what? 250 are you final. This is 250 beta ji. 250 minus here half CV square. Half C V square. 72. 72 into 5 beta. How much coming here? 72 into 5. How much coming? I'll calculate, bacha. You are not responding, bacha ji. Sir, mistake. My side. What is mistake? Tell me. What is the mistake? Okay, energy initial. Half C V square. Half 5. 12 12 ja 144. So I can say this is what? 72. 72 into 5. How much can we get? 5 to the 10. 360. 360 microjoule. So 250 minus 360, right now? 250 minus 360. 250 minus 360. Every microjoule only here. So you can see this is what? Minus 100. Beta minus here. 250 minus 360. 110. 110 in minus. Plus 110. Oh, correct here. Answer is 10 microjoule. Answer is what? 10 microjoule. Yes. Correct, beta. Vedic. Okay, bacha, very good here. I'm very happy to see, bacha, your entire beta enthusiasm. All the best, every boys and girls. Within beta 10-15 beta, I'll start 11th class. Student 11th class, you can join here 10-15. Now, students, I'm going to stop this live session here.